And okay, my mic is working now. Let me tweet this out. And pull it up on my phone so you can see the chat. There we go. Okay. I'm going to give it a couple of minutes. If anyone is here and can validate that audio and video is working correctly, much appreciated. Okay, let's share my screen, jump over here, and we can get started. Let's start with a bit of a refresher on where we're at and what we are doing. So we have this new Rails application. It's up on GitHub at OAuth demo on my GitHub account. And we can walk through all of the commits that we have made yesterday. So we scaffolded the app, basic stuff, and we scaffolded a user resource and a session resource. So when we think about how we're going to restfully architect our authentication system, users new is where the sign-up flow starts, and sessions new is where the sign-in flow starts. And we have pretty lean, pretty simple models for users and sessions, but still usable. We are going with an OAuth only authentication approach. So there's no username and password, no email and password. We're delegating fully to our OAuth providers that we're going to integrate with to drive our authentication. So in order to ensure that the users new and sessions new pages are well structured and well prepared, I like to use a separate layout for those publicly accessible views. So we keep using application layout for all of our authenticated views. And then I create a layout called the authentication layout, which I use for, well, the pages used for authentication. In order to drive our sort of experimentation, we built a really simple rack application that is serving as our example OAuth provider. And we then worked through the authorization phase. Like, what does a client and a provider need to do? Earlier today, I just made a few things to clean things up, made sure we were using the right inflection everywhere, fix some Robocop issues, fix some tests. Let's jump into the code and remind ourselves where we're at and what we're doing. So, as I said, we've got users new. This is our sign-up flow. And we've got sessions new. This is our sign-in flow. I'm not using those aliases at the moment, but we might add them back. We also have our authorizations endpoints, a post endpoint and a get endpoint. This is how we are RESTfully modeling the OAuth flow. And then we have our rack application, which we match on this provider namespace. So if we start on sign in, sessions new, we use the button to helper to post to the provider authorizations path. This is going to be our create action. In our authorizations controller, in our create action, all that we do is redirect to the authorized URL, and that can be on another host. So we build that authorized URL by taking the authorized endpoint and ensuring that we have the appropriate query parameters: response type, client ID, redirect URI, scope, and state. As the provider, when someone is set to our authorized endpoint, we show them a basic authentication form. Ours is just like, tell us your name and tell us your email. We're going to store that information. Inside of the provider, we handle that form submission. So I sort of am manually forcing this to be a get action back to authorized. And all we do there is store that information. And we then redirect back to the client application. And there are two key pieces of information that we send back. We send back the state that the client application sent us when they began the OAuth flow, and we send back the authorization code that we have generated at the end of this authentication flow. So the redirect URI that we use is to the show action. So we come back here, and because we use Rails's built-in CSRF protection mechanisms, we are driving our verification that we are coming from the provider, which is what the state token is used, through Rails's authenticity token check itself. And that's the only thing we're doing right now. So that's where we're at, where we're going. So there were a couple of things that we talked about last time. The first one was, this is problematic. We shouldn't need some useless ID. And the second one is, how do we want to handle errors? Then what we want to start really building today is, once we do verify the state, what do we do here? So that's the plan. Let's jump into it. As I said yesterday, I just needed to take a step back and not in the sort of rush of live streaming, figure out what the routes are supposed to be. And of course, as soon as I step away from the computer and I turn the camera off, it comes to my mind immediately. We are using the plural resources helper here. And what we want and what we need is the singular. And let's actually talk a little bit about the difference here. Let's do provider. So we'll keep it with the plural. When you use the standard pluralized resources helper, the expectation is that you're working with a resource that has multiple records, right? So you're going to have an index view, and your show view needs an identifier to distinguish which record you are trying to view. Rails also comes with the singular resource helper. And this is for resources that only have one representation in your system. There's not many of them. There's just one of them, right? So this is a singleton resource. And so like when you have a show action, you don't need an identifier because there's only one. I don't need the identifier for which one. There is only one. And the convention is to use a singular noun here as well. So now our routes look like this, right? We see that our helper method stays the same, but the actual URLs are simplified. And this is going to allow us to drop the ID that we were supplying. We don't need the ID because we're just going to generate a URL that looks like this. And we can update these. Yeah, provider authorization path. So this should give us everything we need to fix our URLs. Let's get this committed. And on the topic of errors, so if you were here yesterday or you watched the video, we saw when we do it live, everything worked. We saw the show page. I came back and I refreshed that page, and we have our action controller invalid authenticity token. When Rails generates these CSRF tokens, they are signed values that have a timeout. So they're only valid for a certain amount of time. And so it's about 24 hours later, it has expired. And this token is inauthentic. We don't want to show this error message, and we don't want to show like the 500 error page when this occurs. So let's clean this up as well. So verify state, bang, right? It can throw an error. Let's make sure to add a rescue from block. And I confess that I don't recall off the top of my head if the Rails error reporter will report exceptions even if you have a rescue from block. So I'm just going to put this here. And in general, just as an example for the things you can do, we want to report that this happened, but we don't want to. Yeah, okay, look at this. So let's just do this. Provider failed. And you can either like give information to the user or hide information from the user. That's your prerogative. I'm going to leave it here. And we want to send them back to the start of the flow and give them an alert. So if we come back here, we refresh the page again, we hit an error. Interesting. Where does this error come from? Let's look at our stack trace. This is a very bizarre error. Maybe we need to get our URL correct again. Okay, so we get sent back to new. Our layout is not showing alerts though. So let's come in here. Okay, let's wrap our main content in a main. And then we can just use a div, and this can be a fixed top 0 inset x0 mx auto, and we want this is an alert. Just as a basic example. So if we come back here, we can force this. So we've got provider authorization state foo. We get our alert message. Let's set this, let's give it a fixed height, and we can make space for it. I'm not trying to make it super pretty, but we can at least keep everything visible. So pretty simple, standard way to deal with errors. Right? So in this case, this is an error that we are manually raising. Very easy to see that we need to account for this situation. And we just add our rescue from and send the user back to the start of the flow and give them an alert that lets them know that something went wrong. Let's get all of this committed. Controllers and app views. Rescue the error, and the state token is invalid or expired to show the user a useful error message. Okay, so completed a couple of hanging to-dos from yesterday. Now we can turn to what do we do? And let's just start this process over again. Let's actually come back here. We can clear this out and watch the interaction. So we start the process from our application. We get sent to the provider's application. Stephen, email at mail.com. Submit. And we get sent back to the show route, and we have a state, and that state in this case is valid, so we verified it correctly. We have our authorization code. We don't want to, I don't think, show this page, right? So what do we do? What do we do when we have a verified state and the provider has authenticated the user, has provided us with a authorization code? Like, what's the next step? I think the best way to guide our thinking here is like, let's look at what the GitHub web application flow looks like, and let's build that ourselves. So the web application flow is the standard authorization grant type, and that's what we're building. This is the flow you're going to use when you have a server talking to a server, a web application talking to a web application. And the GitHub documentation provides clear sort of articulation of what this flow looks like, right? So at a high level, it's 3 steps. Users are redirected from your application to GitHub to request their GitHub identity. That's the step that we just finished building. Users are redirected back to your site by GitHub. Yep, done with that. Your app accesses the API with the user's access token. Okay, so this is what we're going to need to build out. So we can see these details. You start off, request a user's GitHub identity. So you want to redirect them to the authorize endpoint. You want to send, right? This is what we've seen, the client ID, the redirect URI. Here's something that's specific to GitHub. If you want to suggest a specific account to use for signing in and authorizing the app, there's a query parameter for that. You have the scope. Read about GitHub scope. You have the state, some random string just to verify when I send them there and they come back that they're coming back for this interaction from this provider. Another thing for GitHub, allow sign up. Do we want to allow users to sign up for GitHub during their auth flow? So like they sign up for you, you send them to GitHub, they sign up for GitHub, they have a GitHub identity, then they come back to you, they get your identity, so forth and so on. If the user accepts your request, GitHub redirects back to your site with a temporary code in a code parameter, as well as the state you provided in the previous step in a state parameter, right? That's exactly what we see. State and code, right? That's what we've built. This is the standard flow of the interaction. The temporary code will expire after 10 minutes. Right? This is true of GitHub. The different providers might have different conditions that are true here. If the state doesn't match, then a third party created the request and you should report the process. Okay. We've already covered that, have that error case. So what do we do with the code, right? Exchange this code for an access token. And we talked about this one at the very beginning. We talked about like at a high level how the OAuth flow works. You get an authorization code, and then you convert that into an access token, and that access token is what you use to authenticate to the API. So for GitHub, the way that you exchange this code for an access token is that you post to the OAuth access token endpoint, and you provide a few parameters. You'll see 3 of them are required. So client ID, client secret, the code, and then you can also supply the redirect URI as well. So what we need to do here is we need to get the access credentials, which, as you see here, you're going to get the access token, the scope, and the token type from GitHub. From other providers, you get a different payload. Some providers will provide a refresh token as well. Some providers provide a access token secret. There's some variations there, which is why I'd like to call it the access credentials, because you're getting a whole, JSON object, not a single string value. That is the access token. So we need to make a HTTP request. Just to talk through where we're headed with this. Of course, the third step then, we have our access token. We use that to access the API. The most common thing that you do, and this is encoded into OmniAuth, so you always do this with OmniAuth, is you make one API request to retrieve user details. So on GitHub, that's going to be the user endpoint. And depending on the scopes that you've provided, you'll get back a different payload of user information. Did you, ask to get the email? Did you ask to get the list of repositories? So forth and so on. But we're going to follow this same pattern from OmniAuth. Always make at least one API request to request the user's information and use that to hydrate your user record. So with the, look at this. Thank you, Copilot. With the access token, we can request user info. And then with that user info, we can start to build up our user model and just sign in that user entity in our system, however we're going to do authentication, and then redirect them to a authenticated root route. So like roughly it will be something like user we will get into all of this. Let's remove this. This is a little bit too knowledgeable. And then we'll say if user.save else end, and if we do, we'll sign in the user, and then we'll redirect to user root path. So roughly, we're gonna do something like this. So let's start building this out. Probably not going to get through all of this today, but we can see how far we get. So request access credentials. I'm going to put them here. We need to make an HTTP request. So if you have been paying close attention, you have seen I keep ignoring this down here. I went ahead and created this file before I started the stream, just to streamline things a little bit. This is a pattern that I inherited from Chris Oliver, which I am a big fan of. Have a clients directory in app and have a base application client that just allows you to set up your own API client classes to talk to third-party APIs. I personally, and Chris is the same, I dislike pulling in gems to talk to third-party APIs. There are two main reasons. I'm not going to spend a ton of time on this, but just to talk through my preferences. So one is if I need to talk to two different APIs and I pull in the two gems, right? So I want to talk to GitHub and I want to talk to Facebook because I'm going to do OAuth with both of them. It is actually pretty likely that the HTTP driver that those two gems are using will be different, so one might use Faraday and the other might use HTTP party. One might use HTTPX. One might use HTTP.RB. Right? There's a lot of HTTP drivers in the Ruby community, and different gems pick different drivers. And so you end up in your application using a wide range of different HTTP wrappers, HTTP drivers, as the sort of substrate of these different API wrapper gems. So that's one thing. And the problem there is that, again, when something goes wrong, there's a much wider surface area for you to debug. And you have to be acquainted with a wider surface area of tools. You need to understand, how does Faraday work? How does it structure the world? How does it model HTTP? How does HTTP party work? How does it structure the world? How does it model HTTP? HTTPX, HTTPRB, like, and that's just going to slow you down, and it creates gaps and opportunities for things to go awry. The other thing that I don't like is that these different gems often present the API resources to Ruby in different ways. So you might have one gem that takes a very object-oriented approach. And so every resource in the API maps to a class, and those classes have class methods on them that map to the actions, the sort of RESTful, and perhaps even for some APIs, the non-RESTful actions that are available on those classes. Other gems take a more sort of hybrid functional approach, where the primary classes are the actions you take, and then you like pass in the models you want to have that action occur on. Like I've seen a wide range of different like ways in which to encode an API in Ruby. And this too is just like variation. So when you go to start writing your code for GitHub, you need to get yourself in the mindset of like, how does the GitHub gem structure the world? How does it think about resources? How does it think about HTTP? How do I like write in that dialect? And then when you go to start writing Facebook integrations, you need to switch mindsets. Like, what was the Facebook dialect? How did it keep track of things? And these small inconsistencies and like this context switching you have to do in your brain is costly. And I think that we, as a like community of developers, I don't know, this is just my opinion. I think that we're sometimes too quick and too eager to go and grab a third-party dependency, bring it into our application, and not really think through the long-term costs of that decision, and also like not really think through like the actual costs of rolling our own. And so when it comes to talking to HTTP APIs, I like to always roll my own. And I follow the same pattern that Chris Oliver does. Put everything in a client's directory. Then you can have folders for namespaces. So we're going to talk to the provider, and we can have a client there. And over the years, Chris has evolved this application client. And it's just a net HTTP wrapper. It provides a simple initializer. You can pass in an auth object or a token. Sets up some default headers, default content type, right? You can gives you some ability to work with pagination, and it just gives you these methods: get, post, rec, patch, just HTTP. Make a request, you get a response, and that response is going to be this little response object. You can read through it. It's lean, it's simple, like the whole file's less than 350 lines. And it provides a really solid foundation upon which we can build our own custom clients, or like what I'm going to do now. I'm not even going to build a custom client. I'm just going to use the application client to talk HTTP. And we will go from there. So that is what this class is. Let's now commit it. App clients. Oh, let me actually remove this. I don't need it for now. There we go. So this is how we're going to talk HTTP. I'm not going to bring in a gem. I'm not going to use raw HTTP. I'm going to use this application client class, which is going to provide it's fairly close like an HTTP party style interface. So we need to talk to the access token URL, and we need to pass some params. If we come back here and we look at, okay, how do we pass our query params? We go down to get, and we see we've got a named argument, query. And query takes a hash. You see the example here. Okay, so query. Yeah, we can start here. This is going to give us a response, and we will work with that response. So let's get these two things figured out. So we're building our own provider. So let's just follow the naming convention that GitHub uses. So we want to respond to a post on our access token. And we want to respond with some JSON. Response equals JSON generate. Let's make this a prettier Ruby hash. I'm just going to leave this static for the time being. No need to go otherwise. So we need our client ID, our client secret, the code, and the redirect URI. Look at that, Copilot was useful. So as a reminder, we just put some stuff here in credentials. So our client ID and client secret are here. What is the client ID and client secret? This is what you get when you pre-register your application with the third-party OAuth provider. Right? You always have to, before you start using GitHub or Facebook or Twitter or whatever, as a OAuth provider with your application, you have to register with them. You have to say, hey, I would like to use you as an OAuth provider. Here are my details. The provider uses those details to help render the page, like when the user needs to accept the permissions you request. They can show an app icon, they can show your app name, they can have some links back to your application, things like that. And when you finish the registration, there are two key pieces of information that they will give you: client ID and the client secret. Right? This is client ID. Obviously, this is your identifier for your application with the third-party provider. And the secret, you need to keep secret, which is how we do message verification. Oh, I said, I was like, let me just talk through my thoughts here. I was like, you need to keep this secret. And then I thought, I'm doing query parameters here. Query parameters, you just stick raw strings on it. That is definitely not secret. And that reminded me that we're not doing a get, we're doing a post, of course. So we don't want to look at this. We want to look at this. And we don't want query params. We want a body. There we go. The post body. So let's just do some janky logging here and see if we get to this point and see what our response looks like. We're going to get an error at this point because this method doesn't exist, but that's okay. Well, first we'll probably get an error and get redirected. Yeah. We need to get this working first. To start, let's just put this in a constant in our controller. Close, Copilot, close. So we need the full URL, make sure it's HTTP, not HTTPS. This is the port that we're using, provider OAuth access token. So started post. Sorry. We need to restart the server. Anytime we make changes to our OAuth provider, we have to restart the server because it lives in lib and it's not automatically reloaded. And I should add an else block here to just at least not have it hang like that. So let's restart this again with our else block. Okay. Nice, we got to that error, so let's look at our logs. Come in here. So our response is an instance of application client response. It has the original response as an instance variable. So let's go and see what this object looks like and how we work with it. So this object provides easy access to this parsed response body as well as the response object headers and status code. Okay, and we can add custom content type parsers. We can, so by default, we see it parses JSON into an open struct. We can change that if we want. But what it gives is a headers, link header, content type, and parsed body. Well, that's what we want. So we want parsed body. And let's run this again. Provider OAuth. I wonder why this is taking so long. This should happen like immediately. I don't know, but nuking and paving always solves problems, right? There we go. So now for our parsed body, we see that we have an open struct instance. And we have our access token, our scope, and our token type. These are the JSON values we were sending. Okay, perfect. So we can just return this directly, and we can start to build our request user info method. All right, so we're going to need an access token to authenticate with the API. And we already know that this object have an access token accessor on it. So Copilot is close here. This time, when we authenticate, or I'm sorry, initialize our application client, we can provide a token. Let's go see what this is doing. So our initialize takes either an auth or a token. Auth should be an object that responds to the token method. Token should be a string, authentication token, or API key. If we have a token, in authorization header, we set up our authorization bearer header with this value. And that authorization header is going to get injected into the headers of our request. So all of our requests will have that header. We can set up another constant. Let's look at what GitHub does. These are on different sort of domains. We ignore that. We'll just do this. How about API user info? How about that? So over here, we need to handle a get to API user info. And we need to set up this method. And we can do the same basic thing. Oh, I was hoping that they would have an example here, but let's just take our, we've got name and email, name, email. Oh, and we can also do, let's see here, hey, Rand 1000, we give it an ID. Okay, so just whatever we provide in the form, we want to eventually get back. Let's see if this works. So we get our credential. Now, I just want to point out, I am aware of the fact that the provider that we are building is not checking anything, right? So there are no error paths currently. This is going to be where we're going to dig into stuff moving forward, right? Because we're going to make our provider much more realistic. And so we're going to check these different conditions that are described in different documentation. We're going to look at some different providers as well, sort of see some of the differences in how they do things and think through how that impacts how we need to build our integration, right, in our authorizations controller. So anyway, just to say right now, I do see and understand that we're passing an access token. It's going to get sent in a header, but we aren't doing anything with it. We will add that, and then we will force to go down the error state there, see how we handle it. We're going to take the same approach, but one step at a time. Let's get the happy path built, and then we'll start to explore all of the different sad paths. So, yeah, request user info. We'll just get that. Right. Okay. I messed this up. We need to return the parse body. There we go. And we want to do the same thing here. Perfect. So I need to actually remind myself how we set up users. So we've got email and avatar URL. Okay, so email, we're going to take user info, email. Just what in the world is all of this? And what we should do is keep track of the ID of the user in the provider's world, like what is the provider ID? But we'll get to that. We'll sort of think through and talk through how we want to handle all of that in just a bit. We need a sign-in method. Yes, I do this a lot, so Copilot knows me well. To sign in a user, we create a session for that user. We'll track the user agent and IP address. We will set current session, and we will set a cookie. The cookie key will be session ID. Yep, that looks nice. We can deal with like reading from that cookie to rehydrate current session in just a bit. We don't have a current right now. We'll come back to all of this. Building out things. And then user root path, we do not have a root path. Let's make one. Let's just do application, new file, authenticated HTML.erb. Throw that there. You are authenticated. Hooray. And this will be our root. Application authenticated. And we'll just make this root path for now. Okay, let's restart our server. Because our OAuth provider has some new code. And let's come back. Let's start over from the beginning. So we go to sign in with our provider. This is, let's do something specific. Email. Look at me.com. Ooh, we got far. Look at this. Okay, so our models aren't quite set up correctly. A user has many sessions. Yeah, it always gets stuck if we reload from the browser with our flow. So let's just ignore that. And terminate and restart. I need to remember, don't try to use the browser reload here. Let's come into sessions, sign in with provider, new example, look at me.com. We have a rollback. So we post to access token, then we get user info, and we then boom, 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 in here we try to check if there is a user. What is why are we rolling back? I wonder what is wrong here. Schema. User needs an email. That's all. It needs to be unique. Do we already have some users? Oh, we do have one. So it successfully saved, but did not redirect to root route. Let's get this cleaned up. Let's just try this again. I just want to start from scratch here. You are authenticated. Perfect. User.count. User.first.email. bar@mail.com. All right. Now we're talking. So I think I only have about an hour available, so we're coming to a close here. But nice progress. So when we get the authorization code back from the provider, after we verify the state, we make 2 HTTP requests. We take the authorization code, turn it into access token. We use the access token to authenticate with the API and to request user details from the API. We take those user details and we use them to hydrate a user model, save that, sign that user in, and redirect. These are all of the core concepts that you need to build your own OAuth integration. What are we going to do next? Well, a few things. Obviously, right now, we're forcing everything into what is conceptually for us in our application a sign-up flow, right? User new, always. What if we already know the user? What if they're just signing in? How do we build that? How do we handle both? Okay. How do we keep track of the user information that we got back from the provider, right? So as I said, you definitely want to keep at least track of the provider's ID for that user, because when you go to take other action on the provider's API using that access token, you might need to know that ID. But as suggested by what I just said, you definitely need to store the access token because you have to use that to authenticate with the API for this user. So we need to be storing the access token and probably storing the user information that we get back, How do we structure that? How does that look? What are some of the variables available there? How do we fill out the rest of our authentication system as our application to make this more realistic and viable, right? Where we're going to have some authenticated routes and some public routes. And how do we structure everything? How do we make sure that once a user signs in, they stay signed in until their session expires or it gets revoked? How do we so it's just sort of like, now that we have the core of our OAuth integration, we do need to like fill out our authentication system. So those are like the immediate next steps. After we finish that up, we can then turn to exploring more deeply some of the different options that different OAuth providers provide. So like how we can structure an OAuth flow in a few different ways, what some of the key points of difference are, and how they affect your application and how you want to integrate with them. So wanted to do a quicker one today, only had about an hour. Let's get this committed, and then I'm going to call this quits and we can pick it up again tomorrow. So I'm just going to add everything. How about that? Git commit and handle the provider's authorization code to sign up a new user. And put that up on GitHub. Stephen is cooking. Yeah, I try. Cool. I will hopefully have a little bit more time, maybe an hour and a half or 2 hours tomorrow, and we can push even deeper. My goal is to have all of this wrapped up by Friday. I just want to do 5 days, explore OAuth, and have this demo application that really sort of highlights everything that I know and have experience with. And I'm pretty sure we can do that in 5 days. So 3 more streams. Let's see how it goes. Thanks for stopping by. If you're watching this later, thanks for watching. And I will see you in the next one. Stop the share and end the stream. Peace.